Okay, hello everyone. So we're going to go over homework for the high school science achievement homework. So the basic idea here is that your advisor has read a paper about academic performance in third grade where they're finding that male students are scoring better on science tests than female students. And you're all discussing about whether that's happening in your high school sample. So you've been tasked with two ideas. You want to check and see if males have better science score than females, whether that's true in your high school student sample. And then second, we want to know if reading is related to science performance. And then finally, she thinks that any difference in science scores by gender may not be important after you've accounted for reading performance. So she's asked you to look at that and examine it at your next lab meeting. So this is real data that you have, by the way. The high school and beyond data set is real data. It's a nationally representative sample all across the country of the United States. And so here's the prompts. First, I wanted to know if science scores vary by gender. To do that, you'll need to run a regression analysis or a GLM. Wait, I thought I had these as GLMs. Oh well, so you're running a GLM or a regression analysis to figure out if science scores vary by gender. So what was the analysis that you did? What was the outcome? You don't know?
Oh,
yes. Oh, yes. Go ahead.
Sorry, I'm too casual about it. 1.9% of the variance in science scores were predicted by gender, with males scoring an average of 53.23, which was a significant finding.
Ooh, I got the whole answer. I just asked what the outcome was, but I'll take that.
Sorry. I don't have my sheet where I have all the nice neat stuff. All I have is like my firm write-up. So.
Oh, sure. Okay, so we have, for question 1, the question was, does science score vary by gender? So what kind of an analysis did you do for that?
Basic regression.
Did it say regression, really? Gosh, I must have uploaded the wrong version. I wrote it as regression, and then I went, this is GLM. Change it to GLM. Okay. Ran a basic regression analysis. What's the outcome? Variable. Like what variable did you use as the outcome? Outcome was science. Okay, and what was the predictor? Outcome was science. Predictor was gender. All right, so what was the result there? You just told me, Hannah. You want to go again?
1.9% of the variance for the science scores predicted by gender.
Can you see me typing? No. Okay. Yeah, that was your R squared.
Yep. And so I found that males scored an average of 2.23, which was a significant finding.
Significant what?
It was, I found it at less than 0.001.
Uh-huh. But significantly different
Yes.
from what?
Grand mean.
Not quite.
Oh.
Significantly different from what? This is the intercept, is that correct?
Mm-hmm.
What is 53 different from on the intercept? Do you know? Yeah. 0. Yeah, different from 0. That's it. And you had the p-value?
Yes.
Less than 0.001, you said? Excellent. So far, does the elementary school report agree with the high school or not agree?
It agrees.
It agrees, yeah. Oh, wait, we didn't actually do the second, the intercept, the slope. Oh, sorry, ask your question, but I want to get the slope too.
The slope was negative 2.69, that's what I got. do you report the significance? Do you report the intercept and its significance?
Yes, I would always report the intercept and its significance. There are some instances in which you don't need it necessarily. So really, I'm going to say yes, you want to default to reporting it, but you don't always have to report it if it's not part of your story. Here it makes sense to talk about it as part of your story because here, this is one of your groups. 53 is one of your groups, so it makes sense to say, hey, the intercept was 53. Of course, it's significantly different from 0 because it's 53, and that's really far from 0. And our scores don't range that far, so it's not that strange that it would be different. But you'll never get in trouble for adding statistical significance to this parameter. Okay, so our slope was negative 2.69. What does that represent? How much lower?
Females are from males.
How much lower the female identifying students are from the male identifying students?
And their science scores.
Yes, thank you. Okay, so now we have the intercept, whoops, we have the slope, and we have the r squared. Yes? All right, so now let's do question 2. Question 2, which is science score predicted by reading score? Science score from reading score. So let's look at, okay, somebody else here give me what was the outcome in this one?
So the R square was 0.477, meaning 47.7% of the variance of science T-score is explained by reading T-score.
Yep.
And the intercept, the constant, for me, it was 17.323. And it was significant. The p-value was less than 0.001. And it means the average of science T-score was 17.323 when reading T-score was 0.
Yes.
And this number is significantly different from 0.
Uh-huh.
And B1 is the slope, 0.664. So the mean of science of T-score increased by 0.665. That means reading T-score is significantly related to science T-score.
Yes. Hold on, I'm going to come back here. The average of science T-score was 17.323 if reading was 0. I'm going to change these words average to expected. Does that distinction make sense? So the expected score for someone, a science T-score for someone if reading is 0, is 17.32. It's also, right now within our sample, it is the average. That's absolutely true. But changing it to expected then makes it be about the equation that we're describing and allows us to think about that as predicting what's happening in the future. So that's our expected score. And this is significantly different from 0. Okay, now our slope was 0.664. The mean of science T-score increases by 0.664 for what? Let's get a little bit more detail to this explanation. Does anyone else have more details that they can provide? Uh-huh.
For every 1 point increase in reading score.
Uh-huh. And I think you already said that this is significantly different from 0. I just stopped typing. From 0. I think that p-value was less than 0.001.
Yeah.
Okay. Does this align with the elementary school findings?
You didn't test that, did
They didn't test that.
It does confirm the lab director's suspicion.
Uh-huh. I don't think I'm a terrible speller. Is that right? Maybe it's right. It's not telling me it's wrong. All right, so now the last piece, the last piece of this question. After controlling for reading skill, does science skill differ by gender? I'm not quite mean enough to make you interpret an interaction just yet. So controlling for means that there's a variable in the model that we're not quite as interested in. It just means another variable in the model. Do you remember how when we were interpreting our multiple regressions, we would have to say, for any two people with the same score, or controlling for this variable, then we're going to interpret the other variable. That's all that controlling for means, is holding one constant. So we're going to look at holding one constant in this one. So we have an r squared. I think I asked for an r squared. Yeah, so I told you what to run, a multiple regression of reading and gender on science score. So with this multiple regression, if you did just the multiple regression, then tell me what you found for your r squared.
0.489.
0.489, which means what?
About 48.9% of the variance in science score is accounted for by gender and reading score.
Exactly. How about intercept?
18.714.
Intercept was 18.714, which means what?
For a male who scored 0 on the reading, if you had a reading score of 0, that's really where you said it. We would expect their score to be 18.714, and that is significantly different from 0.
Their science score.
Yeah, their science score.
18.71. Oh my goodness. 18.71.
That's less than 0.
Guys, all those typing classes really paid off in 7th grade. Okay, slope. Let's do the slope for gender. What was the slope for gender? Okay, someone else. Does anyone else have one of these ready that doesn't?
I forget if I put gender as B1 or B2, so it's either going to be 0.66 or negative 2.12.
I think it's -2. -2.12. And so what does that mean?
It means that females, when their reading score is 0, score 2.12 less than students that identify as males.
2.12 less on science. Whoa. And is that significantly different from 0? I just happened to remember what all the significance values were in this table because I just looked at it right before I came over here. All right, next we have one more slope. And that's the slope for reading. What was the slope for reading? Anybody at home, did you all do this with just a multiple regression?
I did the interaction.
No. I mean, that's so cool. Good for you. You'll have a head start on homework for this week, but maybe.
I did multiple regression.
Awesome. Will you give me the next slope?
I got 0.66.
Oh, you literally just said that. I had already forgotten. Sorry. 0.66. And what does that mean?
That after controlling for gender for every 1 unit increase in reading skill, the mean science score of a student increases by 0.66 on average, which is significantly from 0.
Uh-huh. Every point increase in reading skill, we expect a 0.66 point increase in science. This is significantly different from 0. Oh, and you told me, oh, did I get it all? Yeah? That should be italicized. That should be italicized. Okay. Good work. Sorry that was so confusing about the interaction. Controlling for just means it's in there. Depends on is interaction language. So we'll get into interaction language. I would imagine that it would have been a little bit confusing because I didn't ask you for any interpretation of that interaction slope. So you'll get to try your hand at that this week.
The slides on Friday for this week.
Is there what?
The slides on Friday for this week.
I don't know. I thought so. They may not be.
Beginning of class.
Yeah, I don't think we can see them.
Okay, well, let me get them up there for you real quick. Now I have this homework review up front, and then we'll have continuing with interactions. Wait, before I go and put those up, can anybody have any other questions or comments about this week's assignment or these interpretations? Do they make sense?
I have a question about syntax.
Okay.
So what is the difference between running a syntax with like a uni-ANOVA versus like a regression?
Can you define the question a little bit more? Like, what do you mean by what is the difference in the syntax? Do you mean how do I type them? Or do
No,
you...
I have it here typed out. I just wouldn't be able to tell you why I should use one versus the other.
Ah, hopefully homework 1 showed you that there's no difference between one versus the other. The only reason why they both exist is because we had multiple people inventing the same ideas around the same time using different frameworks. But they both give you exactly the same information, and they give you exactly the same results. So, if you're not sure, I would say you can run it both ways and look at it, and maybe one of them will make more intuitive sense to your brain. And that's the one you should use. The GLM is the one that gives you uni-ANOVA. The GLM within SPSS, the GLM menus give you the codes to uni-ANOVA for some reason. But if you run it in a regression, you'll get exactly the same response.
Is there a pro to using one over the other in like a paper?
Is there a pro to using one or another in a paper? The answer is no, there's not, because they're literally the same. The only advantage to using one versus another might be if you're in a field where they only use ANOVAs. It might take a lot of space for you to explain that you're using a regression, but it's the same thing as an ANOVA. Or it might take you arguing back and forth with a reviewer, no, it really is just an ANOVA. I know you're telling me to do a t-test, but I did a regression and it's literally the same thing. Is something that I have had to argue with reviewers before. In that case, just switch it and now it's a t-test. Your results will be identical, there will be no differences. You can just say, I ran a t-test.
There's no like conceptual difference, like in how the research question is framed, like
Nope.
If you're looking at a relationship, like uni-ANOVA is just as good as like a regression.
Yep. That's exactly right. We will get into, not next week, but the week after, we'll get into some situations where there's some slight differences in how the data are organized, which will lead to different results, different choices for analytic approaches, but that's just data structure. Still, the math is all the same. And still, you can do it all the same way. That's why we call this class the general linear model, because we're just fitting lines to scatter points of plots, no matter which one we're using. Okay, hold on one second.